In this video, you will learn about some recent applications of the classical model, including why structured expert judgment was needed and how we went about finding seed questions. What do antibiotic resistance, the impact of breastfeeding on child cognition, and stormwater management all have in common? All three areas are very complicated, with a large number of interdependent, highly connected facets to the issue. All three areas are also filled with scientific uncertainty. While some models or data exist, they aren't sufficient to make conclusive predictions. Thus, the three areas are great candidates for using structured expert judgment. Understanding the future trajectory of antibiotic resistance is crucial for prioritizing the development of new drugs and guiding policies to reduce the use of antibiotics. However, we don't know enough about the emergence and spread of new resistance mechanisms to fully model population-level antibiotic resistance. Although we have surveillance data on historical resistance rates, the history of observations is short. Definitions of resistance change over time, and data isn't collected from all facilities, which means it may not be representative. Even if we had the knowledge to build a good model, we might not have the data to populate it. Additionally, the rise of antibiotic resistance has also been met by a rise in infection control and a reduction in antibiotic prescribing. Adding in these behavioral elements and their dependencies further complicates the modeling challenge. However, experts in the area understand these factors and can use that knowledge as the basis of uncertainty estimates. To better understand uncertainty about the future trajectory of antibiotic resistance rates, we formed expert panels in 4 European countries: France, Italy, Spain, and the United Kingdom. We asked experts to estimate resistance rates, with uncertainty bounds, for 9 bug-drug pairs in each country at 3 points in the future. Because surveillance data on rates of resistance is regularly collected and reported, that created a good source of data for our seed questions. Every fall, the European Antimicrobial Resistance Surveillance Network releases data on resistance rates in the previous year. We were able to time the expert interviews so that seed questions were based on data that would be released in the next update of this report. We finished interviews in October. The data was released in November, so then we could do our analysis of expert performance. The results from the experts were very interesting. For example, let's look at the expert assessments of E. coli resistance to carbapenems, a second-line treatment option. E. coli resistance to carbapenem antibiotics is historically very rare. However, because doctors are starting to prescribe carbapenems much more frequently, and the experts expect the rise in carbapenem use to continue to increase into the future, experts in all 4 countries thought resistance to the drugs would soon start to emerge and spread. Here, the dashed line is based on the median estimate. The dark gray shows the 50% credible range, and the light gray shows the 90% credible range. The experts expect E. coli resistance to carbapenems to appear soon and slowly creep up from 2018 through 2026. Experts in 3 of the countries anticipate a similar pattern for Klebsiella resistance to carbapenems. However, Italy has already seen a frightening increase in these infections. Although the experts were concerned about that sharp increase, many also thought that the rapid national policy response to carbapenem resistance was going to work to stop the increase. Their median estimate of resistance is relatively constant over time, although there is uncertainty around that, and there's a chance the situation could continue to worsen or even improve in the future. Because we have some historical data from the European surveillance system, we were able to contrast the expert forecasts with the forecasts from a set of standard statistical models. We fitted 3 exponential smoothing models with different parameters and an autoregressive model. Let's take a look at the expert expert and model forecasts for Klebsiella resistance to carbapenems in 2 countries, Italy and Spain. Again, the dark gray areas show the 50% credible range, and the light gray indicates the 90% credible range. Our results show that, depending on which set of standard assumptions you choose, the models present vastly different results. This highlights that an analyst or decision maker can't choose between using expert judgment or statistical forecasts. Creating statistical forecasts also depends on expert judgment. It's just the judgment of the modeler rather than of a subject area expert. When we applied the classical model to better understand antibiotic resistance, our variables of interest were mid-range projections of future resistance rates. We had data on near-term changes in resistance rates to use for seed questions. However, predicting the future isn't the only time expert judgment can be helpful or necessary. The Bill and Melinda Gates Foundation is interested in knowing about the impact of breastfeeding on cognitive development, particularly in low and middle-income countries. This would help them better plan their programs. While the impact of breastfeeding is well studied in high-income countries, issues around confounding factors and self-selection means it is still not well understood. In low and mid-income countries, there is little data. Plus, patterns of who breastfeeds and for how long are different in low-income countries than in high-income countries. Thus, the impact of breastfeeding there is even more uncertain. We used the classical model and asked experts to conduct a thought experiment. Imagine you could conduct a large, perfectly randomized experiment of breastfeeding. The cohorts would perfectly comply with different feeding regimens, varying if infants are breastfed and for how long. Of course, such an experiment would never be possible in real life, but experts can use their knowledge and experience to estimate what would happen if it were possible. This was the basis of our variables of interest. The seed questions, then, were based on new analysis of some of the data sets commonly used in this field of work. The results of this study indicate that breastfeeding may have a larger impact on cognition in India than the US or China. Furthermore, the results suggest most of the cognitive benefit of breastfeeding comes from early, exclusive breastfeeding rather than breastfeeding over a longer period of time. This is important to know when designing new maternal and infant interventions. Finally, in another application, we use the classical model to estimate the effectiveness of different stormwater management practices. Because of the wide range of environments in which these practices are used, there is not sufficient data to model how effective a particular option will be in a specific setting. Thus, we presented experts with data on hypothetical scenarios, including geological information and data on storm events. We asked experts to estimate how much nitrogen from storm runoff would be removed from streams by the different choices. The experts built simple models of nitrogen removal and used that as the basis for their estimates, adjusting the results and uncertainty bounds based on the particulars of a given scenario. Here, the seed questions were based on similar scenarios that had actually occurred, so there was observational data available. This study helped policymakers understand what factors drive the variability in performance of stormwater management practices. If you're interested in learning more about any of these applications, including more on how the experts and seed questions were chosen, you can find more information in the references listed here. Thank you for your attention.